Faster than the foundational structure of spacetime itself, it holds the power to stay conscious of it. As a result, it will slowly dismantle this concept, leaving me increasingly anxious with each passing moment. Right now, the sky above us is experiencing rapid changes, and in the near future, potentially within a few decades, it might become unrecognizable. Renowned experts, including deGrasse Tyson, have started to sound the alarm, acknowledging the undeniable alterations caused by the shifting of Polaris. The reasons behind this shift are remarkably unforeseen. Polaris, often called the North Star, has been a consistent and reliable presence in the sky for centuries, offering essential reference points for astronomers, navigators, and stargazers. However, this could soon change, shifting our understanding of the heavens and how we explore the cosmos. Let's explore what consequences this transformation could bring. For hundreds of years, Polaris has been a guiding light for sailors and astronomers, maintaining a fixed position in the sky. Its consistent presence has been crucial for navigation, but that stability may soon be disrupted. In September 2023, a paper published by the prestigious Royal Astronomical Society raised concerns about the future of this celestial beacon. Polaris seems to be entering a volatile phase, possibly heading towards an explosive event, which could result in it disappearing from sight forever, radically changing the sky as we know it. Before contemplating the potential outcomes, let's dive into the properties of the star itself. Polaris is notable for its close proximity to the celestial North Pole, positioned right above Earth's northernmost point. It appears almost still in the sky. Polaris is part of the Ursa Minor constellation, often recognized as the Little Dipper, and shines with moderate brightness, resembling a yellow-white supergiant. It is significantly larger and more luminous than our Sun. However, Polaris is not a single star. Rather, it is part of a complex triple star system consisting of Polaris A and B as a binary pair, with a third star orbiting them. The gravitational forces between these stars affect their orbits and behavior, and any disruption in these interactions could lead to changes in their brightness or pulsation patterns. Yet, the exact nature of these forces is not fully understood. Polaris is located around 323 light-years away from Earth, which means the light we currently observe from it began its journey a long time ago. If Polaris were to explode, we wouldn't observe the effects for over 300 years. It's even possible that Polaris may have already exploded, but we simply haven't observed it yet. Historically, the North Star has held great cultural, navigational, and symbolic significance. Its fixed position has made it a critical guide for ancient sailors navigating oceans and lands. Symbolically, Polaris has represented steadfastness and direction, remaining unchanged in an ever-shifting sky. For astronomers, Polaris has been an essential reference point in studying stellar movements and variable stars. As a Cepheid variable star, its periodic changes in brightness have provided important insights into the properties of stars and the behavior of variable stars. This characteristic has also been invaluable in measuring cosmic distances and calibrating scientific instruments, as its pulsations follow a predictable pattern, making its behavior easier to forecast. Recently, however, Polaris has shown signs of deviating from its usual behavior. These irregularities in its pulsation cycle have intrigued astronomers, prompting further investigation into the cause of these unexpected changes. Instead of adhering to its usual pattern, Polaris has begun showing erratic dimming, leading to concerns that the star might be nearing the end of its life cycle. This behavior aligns with what is typically seen in stars nearing their final stages. The gradual increase in Polaris's pulsation period, once steady, has been traced back to interactions within its star system. There has been an annual increase of about 4.5 seconds in the pulsation period. While this may seem insignificant, it has important consequences. Some astronomers suggest that the gravitational forces between the stars and the Polaris system might be influencing changes in its atmospheric conditions, affecting its pulsation patterns. Others are more concerned that Polaris is entering a critical phase that could lead to an explosion. The similarities between the behavior of Polaris and Betelgeuse, another well-known star in the Orion constellation, are striking. Both stars have shown complex variations in brightness, raising concerns that they might be on the brink of a dramatic explosion. Stars approaching the end of their life cycles often display such irregularities before their demise. NASA has expressed more concern about Betelgeuse, but formal attention has not yet been fully directed toward Polaris. As a Cepheid variable star nears the end of its life, it undergoes several stages, including the red giant phase, ultimately culminating in a supernova explosion. Given the irregular pulsations observed in Polaris, scientists predict that it has entered the helium exhaustion phase, which is typical for giant stars nearing their demise. These irregularities align with patterns seen in stars approaching the end of their life cycles. However, solid evidence of an impending supernova remains uncertain, and astronomers are continuing to monitor these anomalies to better understand Polaris's fate. If Polaris were to undergo a supernova explosion, it would likely be a spectacular event in the sky, potentially outshining the moon and remaining visible for days, weeks, or even months. Its brilliance could dramatically alter our view of key constellations like the Big Dipper or Ursa Major, in which Polaris plays a crucial role. Fortunately, Earth would likely remain unaffected by the explosion due to Polaris's distance and size. While the explosion of Polaris may not be as visually impressive as Betelgeuse's, it could still be visible to the naked eye for an extended period, outshining nearby stars. This would undoubtedly capture the attention of astronomers and observatories, generating widespread interest in both the academic community and among stargazers. However, the impact on Earth's environment or ecosystems would likely be less significant compared to a supernova closer to our planet. But what about the future of Polaris itself? What is its fate following a potential supernova explosion? First, it's important to note that while massive stars generally end their lives in a supernova explosion, this is not likely for Polaris. When a large star undergoes a supernova, its core collapses, triggering a violent shockwave that causes the star to disintegrate. However, Polaris is not massive enough to undergo such a violent event. Instead, once it exhausts its nuclear fuel, it will shed its outer layers and transform into a white dwarf. This transition will not lead to a supernova, but rather to a quieter conclusion as Polaris evolves into a small, incredibly dense stellar remnant. A white dwarf is the compressed core of a low to medium mass star that has used up its nuclear fuel. This remnant, though roughly the size of Earth, will still have the mass of the Sun. Once this process occurs, we will no longer see Polaris as we know it. By comparing the effects of a potential Polaris explosion with actual supernova events, we can gain valuable insights into stellar evolution. For example, supernova events like SN 1987A, SN 2011FA, and SN 2014J have provided crucial data that help us understand what might happen to Polaris in the future. For instance, SN 1354 led to the creation of the Crab Nebula, a cloud of material that continues to expand and emit energy across various frequencies, offering astronomers a rich field of study. Moreover, SN 1987A, observed in the Large Magellanic Cloud, provided essential insights into nucleosynthesis and the mechanics of supernova remnants, such as nebula formation and the release of high-energy radiation. These discoveries can help us better understand the unique characteristics of Polaris. The formation of nebulae, such as the Crab Nebula, occurs when material ejected during a supernova explosion interacts with surrounding interstellar gas and dust, enriching the gas with heavy elements and contributing to the ongoing cycle of star birth and death. The release of high-energy particles and shock waves from supernovae also has significant implications for astrophysical processes and cosmic radiation. To make a definitive comparison, scientists are studying the differences in the production and speed of ejected materials between Polaris's potential explosion and other observed supernova events. By examining light curves, spectra, and remnants from these events, they can predict the possible explosion of Polaris. This research will help determine whether Polaris's explosion could lead to nebula formation or impact stellar distributions in significant ways. Another crucial area of study involves the pulsational variability of stars nearing the end of their life cycles. By comparing Polaris with other supernova progenitors, astronomers hope to gain a deeper understanding of the mechanisms behind stellar explosions. The variation in pulsations in stars approaching death may indicate internal instability or an impending catastrophic event, offering important clues about the processes that lead to supernova explosions. Despite extensive observations and research, space experts remain puzzled by the irregularities in Polaris's behavior. Understanding the causes behind these anomalies is crucial for advancing our knowledge of stellar evolution. Investigating the factors causing Polaris's erratic pulsations requires collaboration across various scientific fields and the development of advanced models and observational techniques. The potential disappearance of Polaris as a celestial reference point raises fundamental questions for astronomical research. Ground-based telescopes and measurements of celestial distances would need recalibration, which would affect the accuracy of cosmic measurements. The disappearance of Polaris would also disrupt navigation systems and cultural practices that rely on celestial markers, highlighting the importance of this event. Polaris's mysterious behavior underscores the need for further studies and focused research. Astronomers must address the complexities surrounding its irregular pulsations and provide meaningful answers to determine the star's future. The study of Polaris is not just a matter of scientific curiosity, but also of practical importance. For centuries, its constant position in the sky has been relied upon for navigation, particularly for travelers crossing vast oceans. Ancient explorers and sailors used the North Star to chart their courses across seas and orient themselves in otherwise featureless landscapes. Similarly, astronomers have used it as a fixed point for celestial measurements, allowing them to track the movement of other stars and determine distances in space with great precision. Should Polaris cease to serve this role or, worse, vanish entirely, it would pose a considerable challenge to modern navigation and the field of astronomy in terms of technological implications. The disappearance of Polaris would force a major recalibration of various astronomical systems. Telescopes and other instruments relying on a fixed reference point would require updates to account for the changes in the sky. This would extend to the myriad systems and devices relying on precise celestial position measurements. Global navigation systems and satellites, which use celestial bodies to ensure accuracy, might also face disruptions, necessitating widespread overhauls in navigational technology. Culturally, the loss of Polaris would also be profoundly felt. For thousands of years, it has symbolized constancy, guiding not only sailors and astronomers but also people from various walks of life who have looked to it for guidance. Many indigenous cultures have woven myths and legends around its unwavering position in the sky. Its disappearance would, in many ways, symbolize a broader shift in how humans relate to the universe and might lead to changes in cultural and spiritual practices centered around the stars. Polaris's eventual transformation into a white dwarf, while less dramatic than a supernova explosion, still marks the end of an era. Once the star sheds its outer layers and begins its slow cooling process, it will no longer be visible to the naked eye. This marks the end of an era for astronomers who have depended on it for centuries. However, the transition to a white dwarf will likely be gradual. While it may not offer the explosive spectacle of a supernova, it will still be a significant event in stellar evolution. The remaining stellar remnant of Polaris will no longer sustain the same bright luminosity it once had, and its eventual cooling will make it increasingly difficult to observe over time. What is especially fascinating about this process is the insight it provides into the life cycles of stars. As we observe Polaris's changes, we are not just witnessing the end of a single star's life, but also a key moment in the broader cycle of stellar birth and death. In many ways, Polaris's fate mirrors the eventual outcomes of many stars that undergo similar life stages. Understanding these processes helps scientists predict the behavior of other stars in comparable situations and refines our understanding of the ultimate fate of our own Sunday. Interestingly, research into the pulsations and behavior of Polaris may lead to further discoveries in astrophysics. Understanding the causes of the star's erratic behavior could lead to breakthroughs in stellar dynamics, impacting our knowledge of how stars evolve over time. The pulsations of Cepheid variable stars like Polaris have long been a critical tool for measuring distances in the universe. By studying the behavior of these stars as they approach their final stages, scientists can refine these measurements, improving our understanding of the cosmic scale. While some may view Polaris's disappearance with unease, it's essential to recognize that these cosmic events are part of a much larger process. Stellar evolution is ongoing, and the changes we observe in the sky are the result of natural processes that have been unfolding for billions of years. The eventual transformation of Polaris into a white dwarf does not signify the end of our exploration of the stars, but instead opens a new chapter in our understanding of the universe. As astronomers continue to monitor and study the anomalies surrounding Polaris, they will undoubtedly uncover more insights into the nature of stars and their evolution. In a sense, Polaris's fading from the sky would not be a singular event, but a part of a broader cosmic symphony playing out over millions of years. Other stars will continue to rise and fall in the night sky, taking Polaris's place as the focal point for navigation and celestial measurement. In the grand scheme of the universe, the loss of a single star is but a fleeting moment in the vastness of time. Yet, the impact on human history, both scientifically and culturally, would be profound. While Polaris's disappearance might alter our view of the heavens, it would also encourage us to delve deeper into the mysteries of the universe, seeking out new stars and new methods of understanding the cosmos. As the scientific community continues to observe changes in Polaris, The importance of this research cannot be overstated. It marks a critical moment in our journey of discovery, expanding the boundaries of our understanding of how stars live, evolve, and die. The fate of Polaris remains uncertain. While the possibility of a dramatic supernova is speculative, the gradual changes it is undergoing present a unique opportunity for scientists to study the processes that lead to a star's death. Whether or not Polaris ultimately undergoes a dramatic transformation, the knowledge we gain from studying it will have lasting impacts on the field of astronomy. As astronomers continue to observe the star's behavior and collect data, they will contribute to a deeper understanding of the forces shaping our universe. In turn, this knowledge will refine our models of stellar evolution and enhance our ability to predict the fates of other stars in our galaxy and beyond. Ultimately, the study of Polaris serves as a reminder that the universe is in a constant state of evolution, and our place within it is but a brief moment in time. While the disappearance of Polaris may be an unsettling prospect for some, it also offers humanity the opportunity to embrace the ongoing quest for knowledge and discovery. Through continued study and observation, we will unlock new insights that will shape our understanding of the cosmos for generations to come.